Hey guys, this is a continuation video for graphing polar functions. If you're in trig, this is from 7.4, and if you're in pre-calc, this is from 6.4. So we're graphing polar functions, and I'm doing the third and fourth different kind of polar graph we're going to be seeing. So the next one is called rose curves, and in the equation of a rose curve, it looks a lot like the circle, where it's a number times a trig function. The big difference is right here that my theta, this is the first time we have my theta having something multiplied to it, okay? Now that number that gets multiplied to the theta is going to determine how many petals my rose curve has, okay? If n is an odd number, that'll be the exact number of petals that you have. If it's an even number, you need to double that even number to know how many petals you're going to have, okay? So let's look at some quick examples, and then we'll work one out. If I have a 2 theta in there, 2 is even, and that's why I'll have 4 petals. Don't mind my drawings here. If I have a 3 theta, I'm going to have, it's an odd number, so the exact amount of petals, 3 petals. 4 is an even number, so I have to double 4, and that's why I have 8 petals. 5 is an odd number, so I keep it, I have 5 petals, okay? If we look at our first example here, it says graph 2 sine of 2 theta. So 2 is just that number being multiplied in front. Remember our rule of thumb from last video? We said cosine was plot top, flip down, and sine was plot right, flip left. So being that this is a sine function, and I do know it is a rose curve because of that 2 being multiplied to that theta, I am going to plot just the right side of the unit circle, okay? So, I mean, again, don't mind my drawings, but you can print these out from my website under the resource tab. I have a bunch of baby graphs that you can just do your homework on. So, being that this is 2 and it's even, I know that this is going to have 4 petals. So I know what to expect. Okay? Now, if it has 4 petals and it's sine, I know that when I have sine, if I plot the right, I can just flip it to the left. Okay? So if I'm plotting the right side, I'm going to plot quadrant 1. So I'm going to go in order like I have been, 0 to pi over 2. And then I'm going to draw myself a little line here. And I'm going to do these in order from what I'm used to. So that'll indicate the division between my first quadrant and my fourth quadrant, I'm sorry. And then, so that'll be me plotting the right, and I'll just flip it over to the left-hand side. Okay? So what you're going to do is you're going to take a minute and plug these in Radian mode into your calculator. I explained how we did that in the last video. Make sure that when you plug it into your calculator, you are multiplying 2 times this value and then doing the sign. So let's pause really quick and plug that in our calculators. All right, so again, I'm in Radian mode. When I plug this into my calculator, again, I'm doing 2 sine of 2 times the theta all the way through. All right, and these are the numbers you should get. If you scroll down, you'll see the rest of our chart. Just want to show you what the setup looks like in the calculator. I'm going to take a moment and plug all of that in here. So at 0, you should have gotten 0. And then 1.7, 2, 1.7, and then 0. And then here we should have gone 0, negative 1.7, negative 2, and negative 1.7. The fact that these numbers have such a clean pattern should make sense to you, being that in any of these petals, I have to start going out a certain amount, reach a peak, and come back that same amount on the other side, and come back to 0. Okay? So, being that the biggest number I go out to is a 2, I'm going to write my increments as 0.5, 1, 1.5, and 2, so that this is easier to read. Okay? So on 0 degrees, I went out 0. I am in the origin. And then I go out to 1.7, then to 2, then back to 1.7, and back to 0. So here's my first petal. Okay? Now when I go to draw quadrant 4, I do start off at 0, but notice that I have negative. So when I get to my over 3, which is this one, it's going to go negative 1.7, so it's going to come back around over here. And then the next one is negative 2, so I'm going to come over here. And then for this one, negative 1.7. So even though I plotted in quadrant 4, it gave me my petal in quadrant 2. Okay? Now I can start to have an idea that this is going to have 4 petals. So if this is symmetric and it has 4 petals, that means my other 2 should be on the bottom 2 quadrants, perfectly centered. Okay? So again with that 1.7, 2, and 1.7, 1.7, 2, and 1.7. Okay, and of course, like I keep saying, when you print these, they are so much easier to see the symmetry. All right, and there is my rose curve. All right, for our last shape, we have lemon skates, and these really just look like windmills or infinity signs. The big difference in the equation and how you can tell that it is a lemon skate is that the R has a square on it. Now I know you see in the equations that those A's also have squares on it, but because A is a number, you technically won't see that exponent of a 2. For example, if A was 4, you wouldn't see 4 squared, you would just see the number 16 in that spot. Okay? So the R squared is your giveaway to let you know that it's one of these functions. Now the big thing you have to remember with these is that when you go to plot your points, you need to isolate R. Okay? So when I go to do this question here where it says R squared is cosine of 2 theta, I need to get R by itself and say that this is plus or minus the square root of cosine of 2 theta. Okay? That's our big difference here. So now cosine will always look like an infinity sign, and sine will always be in the quadrants. But again, that's if you want to memorize some extra rules and tips and tricks. You can remember that always the rule of thumb of for cosine, plot the top, flip it down, and for sine, plot the right, flip to the left, will still continue to work every single time. Okay? So being that this is a cosine function, I know it's going to look like some sort of an infinity symbol, and I want to plot top and flip down. Okay? So my top goes from 0 to pi. Let's take a minute and write that in. And then we'll just mirror it down for the rest, okay? And those values are the same ones that are going to go here. So that'll be my first quadrant. And then I'll go to my second quadrant. Okay, so now let's take a minute and plug these into our calculator. You don't have to put the plus or minus in your calculator. You can go ahead and just start writing that on each of them or as you go. Just do make sure that you put the square root of the cosine and then in parentheses 2 times your theta. Take a moment and plug that in your calculator. All right, so if you took a moment to plug that into your calculator, it should look something like this. Okay? We have plus or minus 1, Remember the plus or minus, well, we wrote it on our paper, and all the way down. Okay? So I'm going to take a moment and plug that in here. We have 1.7. We have 0, which doesn't need a plus or minus. And then on the next 3 answers, we get an error. Okay? And that's okay. Remember that if the cosine of that value gave you a negative, I can't do the square root of a negative. So that just means we won't plot anything in those spots. And then here, we got 3.16 times 10 to the negative 7th. That is like moving this decimal point 7 to the left, which means a tiny, tiny, tiny fraction. So this is like almost being at 0. Okay? And then we get, well, plus or minus here, plus or minus 0.7, I'm sorry. And then we get plus or minus 1. All right. So let's check this out. On 0, I am at 1. So if 1 is the biggest number that I got, I'm going to do my increments to say 0.25, 0.5, 0.75, and then 1. Okay, you are allowed to do those increments however you want. You don't have to draw one ring and then make it all fit in this tiny little spot here. Okay, so I have on 0 and on pi, I have, and you can see that the plus or minus 1 makes sense for both of them. Okay, and then on pi over 6, I have a 0.7, so almost at this 0.5, and it goes in both directions, all right, because it's plus or minus. And then we have 0. And then we're done for quadrant 1. So you can see that this just goes up and in. And then this one gave us that number that was so close to 0. So go ahead and draw it in there. And this gives us this bottom part of this one. Oh, I missed a dot. Okay. So you can start to see it's going to look like one of these. Because if I plotted top and I flip down, this one's going to be in here to close off this piece of the infinity sign. And then this one's going to have it right about here to close this one off. Remember, you plot top, flip down, and vice versa. You could plot the bottom and flip it up. Okay? And that is our last graph today. Okay? So we saw circles, limousins, rose curves, and now our last one was Lehman skates. Remember when you do this homework to skip the symmetry that they want you to plug in. As long as you show me in your homework a chart and your graph, you are good to go.